time we talked about how in the quantum realm, you could be in two places at once. And the way you would do this is, since every particle has an associated wave, you would make your wave wiggle a little bit in one place and wiggle a little bit in another. Since the particle is somewhere in the wiggly bits, you would be in two places at once. So we talked about going to a theater, for example, and now, rather than having to choose whether to sit in the front row or in the middle row, I can choose to sit in both at once. So let's say maybe I make my wave wiggle and in the front row a little bit and wiggle in the middle row a little bit, such that I'm 70% in the front row and 30% in the middle row. This is all fine and well and good for quantum particles. The wave can do any shape it likes, so I can do that. I can make myself partly in the front row and partly in the middle row. This is a phenomenon, by the way, known as superposition. Superposition is just a fancy word meaning we added two things together. So since I added together the state of being in the front row plus some of the state of being in the middle row, I'm in a superposition state. And again, this is all fine and well and good. But we'd like to know what happens if, say, the usher comes along and asks me where I'm sitting. This is a little bit like taking a measurement in quantum mechanics, because the usher wants to know something that was previously unknown, and I, the particle, will have to give some answer. So what are the things that I could say? Could I just say, look, usher, can't you see my wave function? It's wiggling in the front row and it's wiggling in the middle row, such that I'm 70% in the front row and 30% in the middle row. Can I just say that as the particle? It turns out I can't, and that's because we can't directly measure wave functions in quantum mechanics, so something else must go on. Well, am I allowed to say I'm partway between the front row and the middle row? Actually, I can't say that either, because I'm not. I'm partly in the front row and I'm partly in the middle row, but I'm nowhere in between. Now, there's a couple of rules that kick in anytime any measurement is happening in quantum mechanics. So, for example, when the usher asks me, where are you sitting? One of the rules that kicks in is the answer must correspond to the question asked. So if the usher asks me, which chair are you in? I can't say blue, okay? I have to give an answer that corresponds to one of the chairs in the theater. Rule number 2, only certain answers are allowed, and usually those answers are discrete. It's a little bit like having to fill out a web form where there are certain discrete check boxes, and I can't choose something in between, but I do have to choose one and only one answer. So let's just see how this goes. So the usher asks me, which row are you sitting in? Since I'm 70% in the front row already, there's a 70% chance that the answer I'll come back with is that I'm in the front row. At the moment that that happens, my wave function changes so that I'm only in the front row. So the only wiggly part left of my wave is the part that's in the front row. That's actually a phenomenon known as wave function collapse, when the wave function suddenly changes that way. It turns out that it does so in a way that's uncontrollable. I, the particle, don't know what answer I'm going to give, and the usher has no control over the answer that will happen. It's as though the particle rolls dice, and you might think, well, okay, there must have been some way to know in advance. Is it possible that, the particle has some quantum script they read? Then it says, if the usher asks where you're sitting, say front row, that doesn't happen. It turns out there is no quantum script. Bell's theorem taught us that. There's just not some quantum script hiding in the particle's pocket. Now, the measurement did change my state, which is kind of interesting. It means that the usher doesn't actually learn where I used to be. I used to be partway in the front and partway in the middle. As soon as the usher asks, I answer the question. To answer the question, those quantum rules kick in. I can only give one answer, and it has to be an allowable answer. So I'm snapped into one of the chairs, and that's the answer I have to give. But the usher actually doesn't know my prior state. The answer I give is now my current state, and the usher only learns that. Now, does the particle actually go through some process of rolling dice in order to answer? The question is, do quantum particles really fundamentally undergo truly random processes when a measurement happens on them? And the answer to that question is that we don't know. This is an open question in quantum mechanics. However, given the myriad upon myriad of measurements that we've done, the answers that come out are as though the particle did something truly random. They're as though the particle rolled some dice. Therefore, we do model those answers using probabilities.